Welcome to the HDR video part 2. To recap, HDR is a process of taking multiple pictures of the same object using different f-stops and combining them into one final picture that is perfectly exposed in all areas. Also remember that this is a painstaking process that takes a really long time even for one picture. This is Professor Alan Chalmers from Warwick University in London. They have developed a way to do HDR video.
And HDR, high dynamic range, it allows us for the first time to actually capture this data with camera technology, such as the one we have here. We can then manipulate it in post-production and then display it on special high dynamic range displays, and for the first time you can actually see the full range of real-world lighting on your laptop or on your television. Basically with high dynamic range, if the human eye can see it, the camera can capture it, and that's the difference. Whereas before with traditional camera technology, you haven't been able to capture what the eye can see. You either have under or overexposed parts of a scene.
Now with a traditional video camera, when the light shines on the lens, the light overtakes the shadows and you can't see any detail in the shadows or in the light. It makes for a blown out image and really poor quality. But with the HDR camera, you can retain the detail in the shadows and in the light. Even though this is a bad image because of the lens flare, you can still see all the detail all throughout the image.
Traditional HDR video recording was used with two cameras, and then their feed was combined in a computer program process where each part of the video was picked out and then modified.
This is an example from Soviet montage. They recorded this cityscape using two Canon 5D cameras. They used one overexposed feed and one underexposed feed and combined them together to get one HDR quality picture. They also used another HDR process to create a more realistic effect on this cityscape. You can see these highlighted areas were taken from the different feeds to create one final picture.
The problem with the previous version of HDR video recording is that the picture quality was more stylized and there's not a good sense of realistic colors or motion, especially with humans. Here's another example of the two-camera HDR video recording process recorded with three iPhones. Here you see the train going by. The colors are a little bit unrealistic, although you can see the detail of the shadows in the top right corner of the train station. The person that will shortly be walking by in the film has an unrealistic skin tone color.
So the real brilliance of this new HDR video camera is that it records 20 f-stops of light at 30 frames per second. That's real video time. It doesn't have to process after the fact. It just records a lot of data. Every frame is 24 megabytes, which means 42 gigabytes per minute. That's huge. So it actually requires a lot of compression once you come out of the camera. And in order to view all that beautiful footage you just shot with your HDR camera, you really need an HDR monitor, which we'll talk more about in the next part.
Up next, potential uses. Dun dun dun!